Hello everybody! In this video I'm going to stress the Mac Studio M4 Max cooling solution to its limits. I will load both the CPU and GPU cores to near 100% of their combined compute capacity, whereby the machine will pull well above 200 watts from the wall plug. What do you think? Will the Mac Studio be able to handle this? Let's start by reviewing the peak compute capabilities of this system. On the CPU side, there are 12 performance cores, each with 4 SIMD or neon lanes. Each lane is capable of 4 floating point operations in single precision, and double that with fused multiply add, for example in matrix multiplication. The all-core frequency is 3.9 GHz, that comes out to roughly 1500 gigaflops or 1.5 teraflops. On the GPU side, there are 40 cores, each core with 128 SIMD lanes. Each lane can do 1 floating point operation in single precision and double that with fused multiply add. The GPU max frequency is 1.58 GHz, that comes out to roughly 16 teraflops. I will now test the CPU performance in dense matrix multiplication. This will give us an idea how close to the theoretical maximum we can get. As you can see, the system is drawing up to 118 watts. That's about 100 watts on the CPU cores when I subtract the idle load. We are able to reach 94% of the theoretical maximum, which is quite impressive. Now it's the GPU's turn. The power load is similar to what we saw on the CPU. In both cases, the power reported by the MX power gadget is quite a bit off from the power meter values. This time around, we achieved 85% of peak GPU compute. There might be a bit of room left for improvement here. I should point out that I'm stressing only the GPU compute in this test. I'm not loading the texture units, the rasterizer, nor the ray trace engines. In order to load the CPU even more, I will perform matrix multiplication in double precision. As you can see, the power draw has went up to around 127 watts. What is interesting, if I max out the fan speed, the system will allocate even more power to the CPU. As you can see, we are now drawing 136 watts with just the CPU loaded. Okay, now it's time for the torture test, the combined CPU and GPU load. This time around, the power meter shows a draw of over 200 watts. But you can see something interesting in the top right window. The CPU power draw has noticeably dropped, whereas the GPU load is at the same level we observed when we stressed just the GPU alone. Were it not for this, the machine would be drawing closer to 250 watts. It's difficult to say if the CPU is already getting throttled or not, or if this is a side effect of the CPU and GPU contending for the same memory bandwidth resource. With the fans running at 3600 RPM, the studio is pretty loud now. Let me show you how it sounds. I'm going to repeat the torture test by using a different linear algebra library to more effectively stress the CPU. As you can see, the power draw is significantly higher now and peaking at around 230 watts. In the top right window, we can see that the CPU power draw is consistent with what we observed when the CPU alone was stressed. The CPU temperatures are now well in the red territory. If you focus your attention to the top right window, you can see that the CPU is throttling now, and the max frequency has been scaled down by 100 MHz. We seem to have reached the limits of the Mac Studio cooling solution, even with the fans maxed out. Unless Apple moves to a new process node for the M5, I think they will find it difficult to keep scaling up the CPU frequency without revising the cooling solution on the Mac Studio. The M4 CPU cores are already extremely power dense and far more challenging to keep cool than the GPU cores. What do you think? Leave your thoughts in the comments below, and if you enjoyed this video, please click like and subscribe to the channel. See you next time.